So, good afternoon, ladies and gentlemen. My name is Jérôme Gondot with PANanalytic. I'm a global product specialist for online analyzers, and that's going to be the main topic of my presentation here. So it's a 15-minute presentation. If you don't mind, before we start about the product itself, I would like to introduce my company a little bit. So our name is PANanalytic, and we are actually a Dutch-based company, so in the Netherlands. Our name in the past stood for Philips Analytical. So the P was for Philips. We are not part of Philips anymore. We are now part of Spectris, a UK-based company. And we are a global company. So as you can see from the map here, we are pretty much everywhere in the world, I would say, including here in Sweden. So we have offices and engineers, salespeople globally. So what is our core business? Our core business is analytical equipment for material characterization and process monitoring in a wide range of industry, including building material, that's cement plants mainly, pharmaceutical, steel, research, and obviously mining, and that's why we are here today. Those products, some of you might know some of those products here. They are X-ray based. That means they use X-ray as the main component of the product. And here we are talking about X-ray fluorescence with the Axios, the famous Axios here, which is very widely used in cement plants. And benchmark, some smaller product in here. So that's for elemental analysis. And we also have something for this diffraction analysis, sorry. So it's XRD for diffraction, like the Imperium, what we have here. All those products we made here are for laboratory equipment. So sample analysis, okay, small sample analysis, very well defined, very stable and very constant. Now, I have a question. What when real time is the key? What when real time matters? When you need to have the information in real time of the whole material that you have on your belt? Well, the answer is the product that I'm presenting right now. It's called a cross-belt analyzer, and that's a system you install in the middle of your process under your belt. What you can see here, you have your material which is conveyed from one point to another, and it is analyzed in real time. So it's called a CNA Cube. That's a very brand new product we have here. It is not based on X-ray technology, but on neutron technology. It's actually a neutron generator, what you see here. That's the heart of the system. And I'm going to talk about that a little bit more in detail later. But now, what can you expect from this technology? Well, you can expect to have the full elemental composition of your material in real time. Okay, so I'm talking about iron, silica, calcium, aluminum. The element you want, you name it, you have it. Of course, it depends on the application. But pretty much all the elements you want to have, you can have it as long as it can be detected by the system. You can also have some derived parameters, such as mineralogy, but keep in mind that it will be based on a model. So that means that no matter what, it's elemental analysis. And here, there is no need to make a sample. You analyze the material in real time while it is conveyed. Obviously, it is non-destructive analysis. And what you have is the full representation of the bulk of your material. Okay, so you don't have sampling mistake. What you see is the full picture. And obviously, you see it in real time. That's the main purpose of online analysis. Real time, I mean on a minute or 2 minute basis. Well, what is the real purpose of that? Imagine in the airport, you have a control tower that helps you monitoring the entire airport to see what are the airplanes you have, where they're coming from, where they go, etc. Well, that's about the same with the online analysis. It is mainly designed to monitor your process and to know what you have in your material. So, knowing this, you will have the possibility to apply different things to your material further in your process, such as sorting. That means depending on the ore, could be low grade, high grade, you would be able to divert your material one side or another side. You would be able to blend your material when you know exactly what is the composition of, let's say, 2 or 3 different kind of materials. You can well mix them in order to have a very constant flow of material. So that's what we call process control. You can optimize things such as crushing or magnetic separation. That's mainly in the applications such as iron application. And you can also optimize leach pile composition. That's more for copper applications. But these are only an example of what you can do with online analysis, what you can improve on your process. Now, I'm going to show you that this product has been designed specifically for mining. You know, mining underground is a very tough environment. It's dusty, noisy, there's probably a lot of vibrations. So we had to design a product which would be very rugged and handle all these rough conditions. So we made it very simple. We made it small, compact, easy to install, and easy to maintain. Okay, so that it is adapted for mining environments. And I'm going to give you an example, actually. What is the mining environment? I guess you all have been in a mine already. So let me show you a picture, a video, actually, that I took in a copper mine in Poland, it was. So imagine you have your belt in here, with the load very variable. And what you can see, which will come here, it's big rocks. So big particle size difference, big 8 size difference. So you want to make sure all these rocks, what you have, will not interfere with the analysis that you're going to have. You have to make sure that it is reliable. And that's why we designed it so that everything is located below the belt. There's nothing on top of it, nothing interfering with the material. So there's no limitation for material 8, there's no limitation for particle size or variation of load, and it is available for a wide range of belt. It goes from a very small belt to wide belt larger than 2 meters. All right. So let's take a look at the system a bit more in detail. Again, as you will see, it's pretty simple. Well, the principle, the way it works, it's a bit more complicated. I'm going to go through it. But the system itself looks very simple. First of all, what you have is electric cabinets, where you have all the power supply, all the signals that are going to be sent to the system and received by the system. Then, a support frame, obviously, which will sustain the system itself, and the analyzer itself, which is some kind of box. It looks a black box, but inside you have a lot of technology. It's called the analytical box. And a very basic but very useful system of wheel and chain pulley, which will allow you to take the system out and to do some maintenance. I'm going to show you in the next slide. So that's the position where the system will make analysis, and that's the position, what we call the maintenance position, if you want to change, for example, the neutron source, or also if you want to check the calibration. What does it mean? That means that you don't have to stop the production when the system is somehow in maintenance. Or if you want to check the calibration, you can just put some material on top of it while the belt is still running with material. So no need to stop production. Okay, now you might tell me, where's the computer? There's no human interface in here. Yeah, obviously. We don't want anybody to be in the area where it's measuring. Okay? So the computer will be located remotely. It could be anywhere, in the laboratory, on the surface, or close to the analyzer. It's up to you guys. Talking about the computer, we have designed a very unique and user-friendly interface for the user, for the people who are going to operate the system on a daily basis. And that's how it looks like, more or less. You will see that on the right side, you have some information on the system status, and 2 things to do: start or stop analysis. There's nothing more simple than that. On the left side, some filters or element that you want to select if you want to display. Okay, again, the element will depend on your application. In iron ore, you will not detect copper, for example, that's obvious. but you will be able to select those elements in here. And in between the main window, where you can apply some statistic tool, such as running average, batch, whatever you want. Anyway, now let's talk a bit more. Let's go a bit deeper into the techniques, into how the system works itself. How can we, from neutron, get analytical results? Well, it's actually not that complicated. If we take a look at this video here, imagine that we have the material running through the belt, and below it, two main elements. This tube you can see here, it's called a neutron generator. That's what creates the neutron. And those here are two detectors, bismuth germanium oxide detectors. What you see in green is basically the neutron particles generated by the generator, which will somehow interact with the material. Keep in mind, we are talking about neutron here, which are penetrating particles. That means we are not going to analyze only the surface of the material, but the whole bulk. Okay, so neutron will penetrate. And the material will react somehow. It will react and generate gamma rays, what you see now in red. Those gamma rays will be collected thanks to a spectrum, thanks to the detector, and create a spectrum, which is what we've seen in red here, which is basically the elemental signature of the material. From this spectrum, we can tell you what was the elemental composition of your material, which was on the belt for the past minutes or 2 minutes. Again, it's not that complicated, but if we summarize the whole process, we need energy to power the neutron generator. If you come and visit our booth, I will tell you at the end of the presentation, we have a booth in here. You will see some kind of model, mock-up of the neutron tube, which is right here. So this neutron tube will generate neutron. What will happen here, that's exactly what happened in the video I just showed you. The detector will create a spectrum, which will be computed thanks to a computer, and at the end, we have elemental composition. So we come from power, and we have analysis. Now, I'm going to emphasize a very important point, according to me, which is the difference between a source, a radioactive source, and our neutron generator, which is the heart of the technology we're using. Well, if you use a source, let's take an example of californium-252, which is a radioactive source having a half-life of 2.6 years. What does it mean? You guys might be aware of that, but that means after 2.6 years, you will have only 50% of the neutron emission level that you have right now. So you're losing signal, you're losing precision, you're including a drift into your calibration. When you use an electrically controlled generator, you are able to maintain this flow stable. Flow stable means always the same signal, means no drift in the calibration. So that's one of the advantages of using an electric control source. Next one. Obviously, it's electrically controlled, so when you don't need it, you can stop it. You stop the neutron emission, you stop the radiations. So it's safe. It's very safe to exchange the source. It's very safe to transport it. And it is very safe because while you are measuring, if somebody gets close to the analyzer, the source will automatically switch off. Okay, here are the different applications we can manage. We know that we can manage because we have at least one system installed in each application that we have: copper, nickel, coal, and iron. We can do more, but it requires some study. So this morning I got the question whether we can analyze graphite. If you have some other material, you can come to our booth and we will check with you guys if your material is suitable for our analyzer. Okay, but for now we know that we can do those applications. And I'm going to end my presentation with an example of iron application, actually in the area. For LKAB, we installed a system not long ago, September 2013, in an open pit mine in Svappavaara, which is about a couple of kilometers away from here, well, a couple of 100 kilometers away from here. And the goal was to test the system by the customer. That means they wanted to make sure the system was suitable for that process before they put it in the mine. So we did a setup together. So that's how it looks like. So basically, before putting it into the ground, we install one belt here with the CNA cube analyzer right here and 2 return belts. Okay, so that means basically the material was circling around. Okay, so that we could make some tests. I'm going to show you what kind of tests we could make. All right, so that's the kind of test that has been done with this system. So we wanted to make sure that the system was stable on the short and long term. We wanted to make sure that the load variation had no influence, particle size, belt position, humidity, segregation effects, and obviously material composition. So we wanted to see the influence of all these parameters, because on the ground, on the mine, you will have all this mixed together. And we want to make sure that the analyzer can perform properly. You see here, the belt here, it's not symmetrical. Okay? It looks it's more on the one side. It looks like we have more fine materials in between, and the rocks are on the sides. So we have to make sure that this kind of effect does not influence analysis. What we have in here is a lot of dust actually generated by the fact that the material was circling, and after 2 hours, it was getting dry. And because it was getting dry, a lot of dust was generated. In this dust, fine particles. That means material composition was somehow changing. And we could really see it. We could really see that for the first 2 hours, the measurement was stable, and then suddenly the ratio, that was iron ore here, suddenly the ratio between iron and silica was changing. Conclusion on that is that the system passed the test, and the customer decided to put it on the ground, on the mine, where, same area in Mamberget, LKAB mine. So the system was commissioned in 2014, February, so it's pretty recent, but now it is installed, and it is working. Here we see a picture of the installation. So remember my previous picture, we see the electronic cabinet here, the analyzer itself, with the wheel that we can pull out the system, and the production line here. Here you see a fence, which does not allow you to penetrate in the area while the system is measuring. If for some reason you have to penetrate, you will just open the door, the safety switch will be open, and the radiation will go off. Of course, we will switch off radiation, also analysis, obviously, but at least it's safe, there's no danger. All right, just to conclude, as you have seen, we are present worldwide. We have trained engineers. The system itself doesn't contain any mechanical moving parts. So pretty much everything can be handled from remote. So we have a remote service support that allows us to connect to the system everywhere in the world. We don't necessarily need to be on site to control the system. Finally, if you have more questions, you do not hesitate to come and visit us at our booth, which is booth 183, in the first, that's on the ground, in there. And we have a scale model of the system as well, which is not working, not functional. But anyway, if you want to come and see it, we'll be more than happy to answer your questions. So the way it works is usually if you have a kind of material which is unknown to us, we'll discuss about it, we'll see what is feasible, probably ask you to send some samples, measure it, and give you an answer whether our system can measure your material or not. But keep in mind that for copper, iron, nickel, and coal, we know that it is feasible. But that's why we're here. Okay? Thank you for your attention. That's it.